Hi class, Professor Dave here, and this is an example for hypothesis testing for a mean using the 6-step process and using the calculator to calculate the p-value. So let's do an example. Suppose you heard that people spend on average more than 3 hours a day watching television. Hopefully they're not watching the commercials. You took a random sample of 100 people and found the sample average to be 6.2 hours with the sample standard deviation of 1.2 hours. Can we infer that people on average spend less than 3 hours a day watching television? So step one is to develop the hypotheses, and we look at what we're trying to infer, and we do that, and we state that for HA, because HA is what we could possibly infer, and that's less than 3 hours. So less than 3. And the null hypothesis is the opposite of that and contains the equal sign, so it's greater than or equal to 3. But I use equal to because that's the key thing, and I want to emphasize that. So equal to 3. Now step 2 is assigning alpha, how willing we are to make a type 1 error, wrongly rejecting a true null hypothesis. And the problem doesn't say, so the industry standard is 0.05, so we'll use that. So we have a 95% confidence level. Now, step 3 is, does the sample results possibly allow us to infer HA? And we have an average of, the sample mean is 2.6, which is less than 3. So we could possibly infer the alternative. So we're good. Now what's our predictable, step 4 is what's our predictable distribution. And for sample means we use the t-distribution. Okay. Step 5 is we need to calculate a p-value. So let's do that using the calculator. So let me bring in a calculator. Okay. And we turn it on. Clear what we had before. And we go into stats. So stats, and we go to tests. So we'll go over to tests. And we'll do a t-test, number 2 on this calculator here. Okay, and if we had data, we'd put it in here, but we have stats, so we'll go down. The null hypothesized mean is 3, so we'll put 3 in here. The sample mean is 2.6, so 2.6 for that. And the standard deviation is 1.2. The sample size was 100. And we want to say, is it less than? Is it less than? So we go to here and enter. Is it less than 3? So let's go down and calculate. We'll calculate the p-value, so we'll hit enter. And we actually have a t-stat, and I want to write that in, of negative 3.33. And we have a p-value of 6.0 times 10 to the minus 4. So we move the decimal place over 4 places, so 1, 2, 3, 4. So the p-value was equal to 0.123, and I think there was a 3 there. And the t-stat was, it was a 6, yeah. 6.0 times 10 to the minus 4. The t-stat was a negative 3.33. That's basically a z-score, and very unlikely to get that z-score if in fact the null was true. Okay. So our p-value, which is the probability of obtaining the sample result or more extreme, if the null hypothesis is true, is really small. It's really unlikely to get that sample result if in fact the null was true. So the null is probably not true, and we'll go the alternative. And I say probably because it's sample results. Sample results vary, and we could be off. But the probability is pretty low, so we'll take that risk. So since the p-value is less than alpha, we are going to reject HO and conclude there is sufficient statistical evidence to infer that, and what are we trying to infer? To infer that people on average spend less than 3 hours a day watching television, which is good news. Okay, so we'll put that there, and there we have it. Okay, I hope you find that helpful.